Well, hi, this morning. Thanks so much for joining me in my shop here. I'm going to be doing a little bit of troubleshooting on this radio. Well, actually, maybe a lot. While I try to come to grips with some of the observations I've made about the radio's observation, particularly after the last sort of whole system test, if you like. So, let's start with some of the observations. An earlier observation I made was finding what looked like audio in the ABC voltage in the radio. And I found that by putting the ABC voltage from a tube, the I tube, from the grid of the I tube right on a meter and seeing it bop around with the sound coming out of the speaker. I think that's unusual. Number two, the wild volume in the radio. While it was on my bench and I was bench testing it and taking a signal out, everything seemed perfectly fine. Once it was connected to the amplifier, it appeared as if the output was essentially out of control here. If I turned the volume up at all, it was just blasting out of the amplifier and the speaker in the cabinet. Exactly why that is, I don't know, but that's certainly an observation. Now another one was hum coming out of the radio. I mean, hum is not surprising, especially for a radio of this size and this age. What I noticed about the hum, though, was if I operated the tone control, the hum would be greatly reduced. So this suggests to me that there's actually two hums, maybe there's more. One hum is probably right in the amplifier itself, producing a fairly low-level hum. And when you turn the tone control to reduce bass from the receiver, I think that's what you were left with. That's what I think is going on. And you turn the bass up over here, you can hear a lot more hum, obviously coming from here. And so if you think about those three things, there is a bit of a relationship between them all. And I'm not sure, this is a theory, okay, I'm giving you my theory. I've got two theories. So the first theory is a problem in the ABC circuits. So the purpose of the ABC voltage is to cut back the gain on some of the early tubes, the amplification of some of the early tubes, maybe the tubes in the IF also, with a strong signal coming in. So it's an automatic volume control, is simply what it is. But if it's not working right, then there's a chance the relaxed state of the radio is to be highly amplificating. That's my new word for the day. If there's no ABC voltage, then the amplification is high. So having the receiver appear to be wide open suggests no ABC voltage. Why it behaved normally when it was not in the amplifier, and then in the amplifier behaved this way, I'm not sure. That's not adding up for my theory. So what I would look for in that case is something about the ABC circuits that is not right. And what that could be, the most likely thing right away is a defective capacitor. How exactly that would cause this problem, I don't know, but that's part of my theory is there's something going on in the ABC circuits, resulting in the high volume. The high amplification will also take a small hum and turn it into a big hum. So I'm thinking that's part of the picture too. And then the audio, seeing the audio in the ABC circuits, that suggests again a capacitor that has no capacity or something of that sort's going on in the ABC circuit. So that's one theory. Now the next theory, I've experienced this wide open volume control problem before, and it's been related to literally a wire coming off the volume control. So the volume control is a resistor. Here's my resistor, right? And you have the signal coming out of the, are you paying attention now? You have a signal coming out of the IF at a high level. It's going through the volume control resistor to ground or something close to ground or the chassis. And then you have the slider selecting how much of that signal you want to pass on into the rest of the radio. So if the slider is down here, the volume will be zero because the slider's on the grounded terminal, and if the slider's moved the rotating knob is moved all the way up to the top, they're then picking up all the signal that's available coming out of the earlier stages of the radio. Then you're just selecting how much of that signal you want. So what can happen here is this can become disconnected down here. And now, instead of having this volume spread over this resistor, with this disconnected, this part doesn't matter, or anything below the slider, and the slider, it becomes a series resistor. The point is, it's a completely different arrangement, and the effect of it is something that hasn't been engineered. Perhaps in this radio, if that's happened, and somehow the volume control has separated from ground, maybe in this radio the volume goes super high. I've seen stuff like this before. So why would that wire, that's the first thing we're going to look at, is the volume control, and is it properly connected. Now I did have some clip leads right on the leads to the volume control. That could be the point at which something got separated. I pulled the clip leads off. Maybe I pulled a wire off. I've also noticed that the last guy did some soldering on the volume control. So there's a third theory here too, and something I have not explored, and maybe I should have explored it while the whole radio was connected, and that is this control and the function called the expander function in this radio. So I think most people, surely people watching my video, perhaps you understand the idea of compression, where you eliminate the peaks and you try to raise up the quietest sounds, try to shrink the dynamic range, and then move the whole thing up volume wise, and get much better signal to noise ratio, and it's just louder all the time too. But that's also kind of flattens the sound. It kind of takes the life out of it. So it'd be great if that's been done, and it's done kind of accidentally by all this radio equipment, the transmitter equipment. Everything is kind of compressing things a little bit. If you could expand it back out and bring those peaks back out, you would bring the life back to the music, the voice or the sound. I think that's what the expander does. I don't know. You know, with a word like expander, what else could you guess than that? So that's a really interesting circuit. I've never seen it in a later radio. Yes, they show up much later as a loudness control. So a loudness button or a loudness switch. I have one on the stereo right here, a loudness button. And it picks up the bass and the treble when the volume's low. So don't really know for sure what the expander is, but could the expander be causing the effect? Now, I also changed two tubes. I popped in two brand new tubes, and we have this result. So there's quite a few things here that I could look at, but let's start with that volume control. Is that a good idea? Shadow, what do you think? Okay, that was a yes. So let's bring the volume control around here. Maybe this will be over in a moment, as soon as I start looking at it. So this is the volume control, and let me get the close-up camera here. Okay, bear with me for a moment. I gotta get it off here. Shadow thinks I'm getting a toy for her. No, I'm not. She's got her eye right on the problem spot, though. Okay, let's take a look with this camera, and we'll see what we can see. Don't want to disturb it at all. I know the soldering in here was a little... Ooh! No. I think that red wire looks like it's right off. I don't think it's off. So I was just about to say, it looked to me like the soldering wasn't really the greatest soldering in here. Let me set the camera here and focus it right in on this spot here. We'll get a really good look at it. So hang on 1 second here. What are you doing, Shadow? Okay, so here's a closer look at the situation here. I just realized I didn't have my main mic on until just now. Oop. Okay, so I might have been a little marbly in the mouth there. Here we go, though. So I'm going to wiggle each of these wires. See if any of them appear to be actually loose. This would be, if like this turns out to be the problem spot, then I can clap my hands, because that would be good. That certainly seems to be on there. It feels like there's not much wire to it. Well, there's lots of wire there. You know what? You know what I can see there when I do that? Am I crazy? I'm seeing the little tail of wire here, the little end here move. Now, is that because it's actually cold? I don't know. I'm not sure. Okay. Is that even the grounded end? So the other two wires, this wire and this wire, are actually shielded wires. You can just see in the top right corner of the screen there, you can see the shielding, which has been cut back at this point. So those certainly aren't going to the ground. The red wire must be going to the ground, or going, it could be going, oh, it could be going not to the ground, but to another thing. We're going to chase that red wire in a minute. So I grab this one. Now, you know, this one is bringing the signal in. And there's lots of signal. And this one in the middle is sending the signal on its way. And there's lots of signal being sent on its way. So I can't, you know, these are not the connections. This is the one. This is the guy here. So where's he going? And that red wire looks a little suspicious. Is that where it's going? So it's going straight to ground, eh? Well, we're going to have to take a look at the schematic here and just check this, but that looks like that's all that's doing, it's just going to ground. It looks pretty solid to me. Okay, let me get in there with a pair of pliers and yank on it. It's a little awkward to get to this spot here. Really solid there. The only hope for the loose ground is this red wire connection here. The question would be, well, why when I operated this internally in my shop without the amplifier, everything sounded fine? I hook up the amplifier and it just goes wild. Why? Okay, so this idea appears to have failed. This appears to not be the cause. But all that noise you hear is my cat playing in the background. Let's take a look at the schematic at this point. And we're going to study it for a little while. And come to grips with a number of things here. Okay, so we're looking at some of the front-end circuits, and I think I'm going to start right here just talking a little bit about what is happening right at this point in the radio. So at this point, picking up, you should have a very strong IF signal coming out of here, in fact heading for this last coil. This is the replaced can right here. So we'll see this on the next page. So what's happened is the signals come in from the antenna, it's been mixed in here with the oscillator signal, and out of it comes one of the products is the IF frequency. That's a terrible way of saying it, but that'll do for now. So let's look at the other part of the schematic here. That was a really terrible way of describing it. So here's that last tube. So coming out on the plate and going through the transformer here, this changed transformer in this radio, is the IF output at 456 kilohertz. Now that's fed into this tube, basically through a rectifier. So the output from the transformer here is fed between this cathode and these little plates. See how it's connected up to the plates there? And the result of that is, instead of having a nice sine wave signal, that's my sine wave signal there going back and forth, you end up with a rectified signal. Maybe half wave rectification, maybe full, depends on the radio. This one's a halfer, I would say. So now you also get, along with this, I was showing you this kind of wave shape, if you like. Now throw that onto a capacitor like this one, and that starts averaging out, starts to integrate into a DC voltage. It'll actually be kind of a choppy DC thing. That's what I would imagine. Depends on the size of this capacitor, the size of these resistors. And from here, things start getting a little bit complicated with this because of these resistor networks. Look at this thing down here. Ay, 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 ay. And again, just one sec while I just poor cat. She's gonna scratch a hole right through the shop door there if I didn't let her out. Oh, she doesn't go out. Typical cat. So coming down this line then are two things. This half-wave sort of partially integrated output signal coming down here, and that contains the audio and a DC voltage, which could be thrown away, but in this radio and most radios that DC voltage is used for something very, very helpful, the automatic volume control. So somewhere they need to separate out the AC signal from the DC signal. So let's just look. So it would be a capacitor blocking. So I don't see any, there's no blocking going on here, no blocking going on here. This is going down to, where's it going? Where's it going? Hey, where are you going? Coming from. So it's a phono input. Phono input here. Phono tips. Switch so and so for phono attachment. Shielded leads. So a switch, eh? Huh? I don't know of any switch. Switch for phono attachment. I'll have to hunt that down. Where's that? On the end of these shielded leads. That should be easy to find. So these leads are just exiting from the location of the radio where the circuits are to the back of the radio where it can meet up with some phono tips. Must be the kind of plug cord that's coming over from the record player. Okay, and back to where we were. So okay. So here we are. We have the audio and we have this DC voltage, and we're trying to separate them here. Send the audio on to the amplifier, and we're looking for the blocking capacitor. So it looked like that switch just shorted these leads together. So it's going out on this wire, it's coming back on this wire. That's the audio from the radio. The DC would still be on it. Was there a capacitor down here? Whoops, wrong way. Was there a capacitor involved? Oops, here. No, it's just the wires and the switch, which really does show it. Shorting. Capacitor here, interestingly enough, but that's not involved. So no, so there's nothing blocking DC yet. Back to where I was. Here we are over here again. Down from the diodes. So out and back. And now we reach the volume control. R, whatever that number is. R, whatever. One end grounded, we saw that when I checked it. It's definitely grounded. This is where if this ground is off, then this circuit will behave quite differently. I look right out of, this is out of the back tab. So let's continue let's continue on just following the sound. So the DC would be here. The DC would be impressed across this resistor. But it can't get through here. So you can't get that DC voltage that's rectified up here through this capacitor, and this is quite typical of how this is done. They usually put the capacitor right on the slider here. So on this side it's all audio now. The audio is sent right to this grid. This tube, its second job, this is a 2-job tube. Second job is to do that audio amplification and send a stronger signal off to the rest of the radio. This radio's got one heck of an audio amplification system. So in a lot of simpler radios, the audio from here is sent straight to the output tube, to drive, you know, a tabletop radio or something like that. But in this case, there's a lot more tubes involved. Now let's take a look at this thing for the first time and try to get a grip on what is happening here. Volume expander. So it's showing in the on position. So in the on position, this is nothing. This is not connected. And so this is the output from this amplifier tube. It's on the grid. Oh, listen to my poor cat. My poor cat. Yeah, they want to go outside, but I'm concentrating here, trying anyway. So this is a plate circuit. And this is the plate circuit. So the plate circuits from this expander is basically coming up to the same point as here. So the output of this expander tube is showing up here. Why is it maybe you throw the expander switch and does it bypass this amp? No, it can't. No, it can't. Well, you're sticking a ground on here. You're sticking a ground on this. So if you turn the expander off, then the output from this tube is no longer involved in anything. It's just cut off. In fact, the B plus is cut off from this tube down here entirely. And then what's this tube doing? So this tube is getting its signal. This is getting its signal through the cap. It's grounded. So this is going to quickly go over my head what they're doing with this tube. So the expander amp, the output coming on the plate is applied to the screen. So I may be trying to use some kind of a phenomenon that can be utilized in these tubes where it has some kind of non-linear amplification. So louder things are amplified even more than quieter things, and that would give the expansion. So this is the expander amp. This is the expander. Okay, so maybe this is just an amp, basically isolating away this guy from the rest of the circuitry. Maybe that's what it's really doing. And then they can also control the circuit around this tube much better, having this one kind of buffering it away from the rest of the radio. I think that's what's going on here. So assuming that, then what comes out of here is just the rate. Where's the signal coming from? So let's follow the expander amp input back. Okay, so here's something coming out of here. Coming out of here. Alright, so this would have to be operating for this thing to get any kind of signal. The signal's boosted, fired into this thing. And the output of this guy is then fed up almost right back to the input. Wow. What? So there's something more going on here. Then when you flip this onto ground, depends how big this resistor is, but that's putting a ground in the middle of the volume control. It's putting a ground here. The sound signal is coming in here. Is it just killing it? Sorry about that. So it basically you throw this ground on. The signal from the radio is cut off at this point. Again, it depends how big this is. What is that? 18? Anybody make that out? 16? 16 maybe? 16? R16. And R13. Well, the volume control is named in the parts list. The volume control is named right there. 15. 16, 17, 18. So, wow. Okay, so how big are these? So 17. It's not 17. What was it again? It was... Oh my gosh. This is going to blow my head apart pretty quick. The volume control number right there. What are you thinking here? I think it's 16. There's 17. 15. 16. 17. I think it's 16. 15 and 16. Go the right way. 15. 15 volume control. 16. 5600. Now, what's the resistance on the volume control? They didn't write it here. Why didn't they write it here? 5600 volume control is typically 500,000, somewhere in that range. It's about 10% of it. About 10%. So looking at the volume control again, this is 10% of this, I'm guessing now. And this tab is only part of it. I don't know if putting a ground on here would kill this. I mean, if they wanted to kill it dead, wouldn't they just forget this resistor and just ground the heck out of this thing? So what I'm trying to figure out here is, in one mode, with the expander off, the signal travels a typical route. With the expander on, the signal is not sent through here, but sent down through these guys, and then on its way. That makes a lot of sense to me, and I'm just trying to prove that that's how this really works. So if this is killing the volume here, then there's going to be no signal on the grid. There's going to be no output here to amplify down here. So that doesn't even make sense. So what this... that. Maybe this drops the volume a lot to make room for this. It doesn't really make sense. They would set this up, pad it in such a way that it provides back a very similar signal level to what's coming out of here, because it's feeding into essentially the same place, isn't it? Except for this R19. Oh my gosh. So I think, an interesting question would be, is the expander on right now, or is the expander off? I should be able to figure that out by looking for what? I mean, I got the back of the switch here and the 4 terminals on it. Is this tab, so there's a, I can, excuse me. I know where the volume control is. I can find this tab. I can find this resistor. I can check to see if it's grounded. This one, off the back tab. Okay. Let's check that. Let's find out the position of this switch. Sounds like square one to me. Let's go do that. Okay, the position of this switch. The switch is located right up here. Spin around. Right up here. So there's the switch. Okay, it's got a gripping long, like wild wire coming off of it. A wild wire. So we wanted to check for one of those pins to be grounded. It's the one that goes to a resistor. So here's a resistor to ground right here. I can see it. resistor to ground from the back of that switch. I don't remember that. Okay, gotta look again. Resistor to ground. So when you turn it off, you apply ground. Now I'm seeing a let's track some more stuff. There's a resistor going to ground off of one of these. No, there isn't. This switch has no wire hooked up to it, but there's a wire on every one of those terminals. Well, I'm not reading this right. I'm not reading this right. So these are the pins on the back of the switch. Here, 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 and here. To ground. Maybe one of those other wires goes to ground. Wow. Okay, let's start here. Yeah, starting with the switch isn't working out. Let me start here, find this, and work my way back from there. Why, it's the simplest stuff all the time. Volume control. There's the tab right there, and again, I suspect this control was replaced, but I'm not sure. So here's the wire. Oh, the wire goes straight to here. That's not right. There's supposed to be a resistor in that wire. Oh my gosh. Maybe it doesn't make any difference where you put this resistor. Maybe that's what's going on. So, wow, it's just a switch. Oh my gosh, does it get any more? Does it get any simpler? Two wires soldered together, I think that's simpler. Not much simpler than a switch though. Okay, what's happening? I see the case is cracking on this switch too. It's got a big crack down. There's a crack there too. I don't know what I'm doing. Let's poke around. Let us poke around. Just poke. Poke, poke, poke. Nobody likes each other? Nobody's friends in here? Oh, what did I do? I think I bumped a wire. Oh, there's something. 200. 200, wow, 200K. So this resistor is a brown, black, yellow. That's a 100K resistor there. Must be paralleled with something. 50K on there. Resistors generally don't go down. Okay, can we flip the switch? Not too hard. What happened? Goodness knows. So there's the full resistance now. So the resistor is 100K. Or 10K? What did I say? 100K. I don't know. I'm not getting it here. It's not coming through to me. Maybe it's this way. I just haven't done it right. So what I'm looking for is shorted terminals. You know, it's a switch, right? Hey, there's a 0. Not a 0 here. A 0 here. Does the front of the radio help me with this switch? So there's nothing written on the front of the radio to tell me left or right for on or off. So if I were a radio designer, it would be off this way and on this way. I would turn on So that would, ooh, that switch didn't sound great. That sounded good. Sound okay. That didn't sound too good. You could hear two quick clicks in there. I'm stumped by a switch. Well, let's trace some wires out of it. So we know the blue one goes up to the back of the blue one goes up to the back of the volume control. And this one comes right to here. Put a little more light on the topic here. Comes to this terminal here in the middle of. Okay, it looks like it connects to this little resistor and then heads to these capacitors, and who knows where it goes from there. So that's not easy to figure out. So resistor to ground we can't find on the schematic, and then we've got this wire coming all the way over to here. So a new theory. Why did this radio work fairly well? Because even though it's trying to blast out its volume, it can't, because the tubes were so weak. There was no, and the alignment was so poor, there was no blast coming out. And that leads me to another possibility. This is a real long shot, that the last guy working on the radio encountered this exact same problem and dealt with it by weak tubes and poor tuning. That's far-fetched, but it's a story. It's a story, all right. What am I going to do here? How am I going to sort this out? I'm just trying to figure out how this radio is put together. Is it possible the guy replaced the switch and got the wires messed up? This wire hanging out like this. This resistor apparently in the wrong spot. Yeah, that's what it sounds like. Chances of replacing the switch are low. It's just low. This wire doesn't look right either. It's bent in a funny shape. Like the shape is not rational. It's bent as if it's going around a much larger switch. That's what it looks like. I'm talking about the blue wire and how it's bent out here. I'm really reaching for it now, aren't I? There's the crack. Ooh, lots of cracks. It's stress cracks, of course. Brings airplanes down. No reason why I couldn't stop a radio from working. There's the resistor. There's the ground connection. I'm just making sure I'm not wrong about anything I've kind of concluded. There's the blue wire disappearing through the hole and reappearing at the top of the hole, and then going up, and you can see it's going onto that tab. Pretty thoroughly soldered there. We have this other wire. It's coming all the way up. It's just kind of out here. It's actually hanging way out of the radio, like it's hanging out. It's hanging out, which is just not normal. And it comes up, and then it's just kind of shoved in here. It's interesting. Now this was the resistor that had popped off, which I re-soldered. Now you get a good look. I re-soldered here on the basis that that must be where it goes. I didn't actually figure this out. It looks like it took a soldering iron hit or something on it there. I don't think that's evidence of a failure of any sort. It doesn't look right. It looks like just somebody whacked it. Maybe I whacked it. So this wire comes up to this terminal here, gets on this resistor, brown, black, yellow, gets into here, and goodness knows what happens after that, because it meets up with a couple capacitors. Look in the background. See, look at those paper capacitors back there. Yikes. It's a lot easier to explain why a radio is not loud enough as opposed to why it's too loud. That's really not your normal thing to be chasing down in here. Oh, lots of interesting information back there. Underwriter's lab inspected. Patent pending. I wonder if they ever got patents for all these things that had patents pending. Well, I don't know. I don't know. Yes, it's an I don't know video here. I think we're going to have to start playing this thing again and listen to it and see what's going on. Last time I did this, it seemed to work fine on my bench, in a bench setup. So we're going to replicate that. Maybe something changed. Maybe something happened. I did replace a couple tubes. Did I not test it after that? I think I did, didn't I? I'm going to set it up again anyway. Let's listen to it and see what happens. Okay, I think we're ready to give this guy a go. Put on my headphones here. So you can hear a little bit of hum from one of my microphones here. If I turn it up and down, you can hear a hum coming and going. I'm not sure what that's about. That's not the radio though. In fact, I'll keep that microphone turned off completely. This is the radio feed here. It's got a pretty good hum on it already, and this isn't even operating. Now, right. Let me just fiddle with the volume control here. I was hoping the hum would come and go. Let's make sure it's turned down. It is. I think we're ready. It's plugged in. So this is going to monitor the AVC voltage for us. I'm taking it out of the Magic Eye grid. You all ready, meter? Okay, here we go. Power on. Now last time I did this in this exact configuration. By the way, I may not have mentioned I've also pulled out the 45 tube, so it's exactly the way it was before on my bench when I was able to operate it and control the volume. No problem. It's hooked up to enough antenna that we should hear something. Now the problem here, in a sense, is this isn't the only volume control. There's a whole series of them. So exactly what the volume state is here, this is turned down all the way. So I remarked earlier about the audio being in the AVC voltage. I'm gonna withdraw that comment and say I'm not gonna withdraw that comment. I'm putting the comment right back. So I'm picking this off from the grid of the Magic Eye tube, okay, which should not be doing that. It should be a steady amount here. The other thing is the volume is turned right down. I can hear it. Right down. I'm going to turn it up a bit.
Renovations has you covered.
So you see there's a heck of a lot of volume here. Maybe there always was. Let me cut it back on my mixer here. And then we'll turn it up.
In home renovations.
How
For
easily
29
fooled.
years, you've been able to count on us. Visit letitrain.ca. That's letitrain.ca. Job done.
Hey there, it's Jeff MacArthur. This past week I was on the road, actually went to Calgary for the Canadian Country Music Awards. Great time, full of a lot of great parties and, of course, great country music. But when I got back...
Okay, let's find out what this control does. So I think it's switched off.
It might sound a little funny, but it's
I'll
actually
switch it
true.
on.
This past week reminded me just how important your pillow
So I
is
got a little
to
more
a
volume.
great night's sleep. My Pillow is just so comfortable. It keeps its shape, and it actually stays cool all night long. So no more getting up at 3 in the morning.
And
so you
it's
can
like
flip
took
the
a
pillow
moment.
to
It seemed to take a
cool
moment.
side
I don't know
or
why that would
readjust.
be.
And My Pillow actually comes with a 10-year warranty. Yes, that's right. It's guaranteed to keep its shape.
Isn't the Switch
for the
interrupting
next
B+?
decade. So how do you get your My Pillow? Just go to mypillow.com.
Okay, so
and
that's
click on the
off.
two-pack special.
It seems
Two
to be
premium
doing
My
something.
Pillows for
Is
just
there B+ on the back of that?
$69.98 US. It's only $34.99 per pillow. It's the lowest price ever offered, but you have to use
It was
my promo
switching the
code
B+ to
640.
the expander tube.
Thanks for calling 1-800-GOT-JUNK.
None of these got B+
How
on
can I
them.
help?
Can you help me with spring cleaning, even if it's not springtime?
Sure, we can do that. We bring the springtime with us.
I'm talking about the house, the garage, and the yard. This is going to be a lot of junk.
Our truck holds 7 times the volume of a pickup truck, but you pay only for the percentage of the truck you use.
Will your people help me move this stuff?
Leave it exactly where it is. We make junk disappear. All you have to do is point.
Are you willing to come after dark?
We work until midnight, 7 days a week.
How much lead time do I need to give you?
We can be there in 90 minutes. Springtime, anytime.
You can't imagine how happy this is going to make my wife.
It makes us
There's a
happy,
wire that
too.
goes from this switch, goes straight to a 2-pin. Let's check that out.
When you want to give happiness, call 1-800.
Or visit 1-800-GOT-JUNK.
It's going straight back to what I'm pretty sure is the expander tube. Right onto pin number 2, 3. Pin 3 of the expander tube.
Existing Capital Direct's clients surveyed would recommend
Sounds like a
Capital
break.
Direct to family,
Three
friends,
of the
or
expander.
colleagues. Hi, welcome to Volksfest, and love this huge purchase bonus or finance from 0% for up to 72 months. Holy yeah, and with an additional $500 in finance cash on other select trims. It's even got optional third row seating to fit up to 7 people. Get
Switch the expander
There's a deal on
on.
the ride you've always wanted. That's pretty exciting. Volksfest. Offer ends September
B+
30th.
coming
Visit
here.
bw.ca for details. Try Sparton.
Oh, yeah, through here. And then here. Let's go straight to the supply. This is B+, through here, through here, through here, down here, down here.
The HOV lane and the left lane.
Pin 3 should have B+ on it.
It's heavy going here from the Fort Finch. So we also have some troubles on the westbound 401 Express Victoria Park. It's right underneath the overpass. The right lane's
The
blocked.
expander
Heading
tube,
into
6K7. Let's make sure I know which one's the
and
expander
just
tube
before
here.
Kennedy for that. Now,
Spot.
eastbound 4 Express at Young.
Expander and reacting expander
The right
tube.
lane delays from Avenue.
No, I don't. I'm on the right, I'm on the expander.
Heavy going. We've got a crash on the
This tube.
downside. The left lane was blocked.
Expander
We've just had it clear away. And off the
About
highways,
it.
we've got problems now at Seals and Leslie, and one in Newmarket at
And then,
404 and Davis Drive. This is a 2019 Lexus RX 350
So-
as well as 11.9%
So
APR.
this, so I believe it should work as one pin should always have this B+ on it. And when I operate the switch, another pin should show B+. Oh, this is the one with the wire going here. I know which one this is.
Global News Radio 640 Toronto.
Okay, let's go back.
Wireless Entertainment Company. Radio 640 Toronto. This is Global News at 9 o'clock.
And a very good Friday morning, Friday the 13th. I'm Jamie Tawil, few
Friday
clouds,
the
and
13th.
16 degrees here at Sugar Beach. Fire crew still on the scene of a 2-alarm blaze in the East End. Flames broke out inside the garage of a home under construction on Westburn Avenue. That's in the St. Clair Vic Park area. Happened around 3:30 this morning. The fire is spreading to the 2 homes that are under construction, as mentioned, causing extensive damage. Some neighboring homes have been evacuated as well. Still no word on a cause, but the fire already being considered suspicious.
For it to spread so fast and to be so fully involved when we arrive, that definitely makes us a little bit suspicious. We'll have our investigators and the police investigate this thoroughly to see. We're also having reports from neighbors that people were seen in the area just before the fire.
The good news is no injuries have been reported. With an absent Justin Trudeau, the 3 main opposition party leaders spent the first federal debate attack attacking his economic record, especially Conservative leader Andrew Scheer. Scheer specifically targeting the federal budget, the cost of living in the country, and the carbon tax as Trudeau's downfalls. At the same time, NDP leader Jagmeet Singh and Green Party leader Elizabeth May battled for what many say will no doubt be a third-place finish.
We have a solid position, unlike the Greens, on a women's right to choose. We have a solid position when it comes down to national unity. We have a belief that we can't leave workers behind, and we strongly believe that we should not be putting Mr. Scheer in the Prime Minister's seat, unlike Ms. May in the Green Party, who believe that's the right choice.
Mr. Scheer, on the question, and then...
Those were absurd statements. I'm awfully sorry.
Meantime, today, it'll be a busy one for all party leaders. Justin Trudeau making a couple of stops in Quebec before attending a rally in his hometown, Montreal. Elizabeth May headed west for an event in BC, while Singh and Scheer will both be sticking around the GTA. It appears those government carbon tax stickers aren't exactly sticking. The Toronto Star has learned that those mandatory decals that are there to warn you about the federal carbon tax are peeling off. We get that
75 degrees.
Dave Woodard.
According to an industry source who spoke with the paper, the stickers were apparently meant to be stuck on metal surfaces indoors.
60.
So now that they've been exposed to the elements for a few weeks, well, they're not staying put. The stickers are mandatory for gas pumps to display, and retailers could face a minimum of $150 daily fines if they don't have them up. The government hasn't heard about any problems with the stickers just yet. Energy Minister Greg Rickford telling the Star they'll continue to monitor the situation to determine if there are significant issues with the adhesive. Dave Woodard, Global News.
Issues with the adhesive. Okay, so what I'm kind of seeing here is a B plus of 30 volts being switched. I think it's, I can't remember now, I think it's from this wire onto this wire. Okay, so that seems to be okay. The other side of the switch doesn't seem to be closing, and doesn't seem to be wired right either. So let's check the switch here now. Okay, so these terminals are shorted. These other ones should be too. And this is where I get a resistance reading, isn't it? 100 and 200,000 ohms. Now if I flip the switch, I get the same reading. Oh my gosh! I gotta look at that diagram closer. Okay, so that's closed. Well, this other side is open. That's not how this switch works, is it? I thought it was closing both. So I'm kind of jumping in here after working on the video and the work I did up to this point. So there's another 15 minutes of me fooling around, which I'm just going to throw away, and here I am live again, if you like. So in watching my video, watching the work I did, I realized that I'd gotten right to the point of the problem, and then I just hadn't whacked the nail on the head. So I'm going to do that right now. So I have my ohm meter here clipped across part of the switch up here, and I'm going to flip the switch. One side should be, that should be shorted. I'm just right on the terminals of the switch. But it's not shorted. It's reading 200,000 ohms. In fact, it's reading same thing no matter which way you flip this. Oh, did you see that jump there? So what we've got here is a defective switch. The implications on that, also I had muttered something about this isn't wired the way it is on the schematic. But that's not quite true. On the schematic, the position of this resistor is shown in this blue wire here. And all they've done is just installed it this way. It amounts to the same thing, but only if the switch actually closes. The switch is not closing. So I believe what that means is no ground is being applied to that back tab on the now I'm having double thoughts again. Double thoughts, triple thoughts, quadruple thoughts. Closing the switch puts that resistor, you can't quite see it here, there's the blue wire, puts the resistor to the chassis on this tab. Which is not happening. The other thing that's bizarre about this is this resistor is not the right size. It's supposed to be 56K and it's 100K here. I thought I'd really nailed this down. What I thought was, okay, so if this switch doesn't close, then that back tab doesn't get shorted, and then the volume stays high. That's my thinking. The volume coming out of the volume control is way high. This should bleed it down. There's too much different here. And you know, I'm studying a photograph that I picked up off the internet from Radio Museum of the back of this radio, somebody else's version of it, and things just don't look exactly the same in there. And it's not good enough picture to really see the wiring back here or anything. So, you know, the upshot is, if this switch isn't closing, I should close it myself. Now, interesting enough, it's closed when the other one is open. Oh my God. Okay, when the switch is off, the B plus is interrupted to the expander tube, and a ground is placed on the tab on the volume control through this resistor. This one being 100K, and in the schematic it shows it as half that, 50K. I should apply a short here, make sure the expander is switched off, see what happens with the volume. Now that should also affect the volume right here as I'm working on it here. Let's give it a try. Let's give this a try. Okay, so the expander switch is off. If it were working properly, this resistor would be grounding that tab on the back of the volume control. So the theory I'm going on here is yeah, never mind the theory. Let's just do the test. Okay, power on. Now we're going to be listening to this through my internal sound system here. That's why I've got my headphones on again. A little bit of volume. There we are. Now the way I have this set up, I can't tell if I've got, you know, if this is excess volume or not. So I've got the shorting leads clipped in here. I didn't want to stick my fingers in the radio. So when I clip this, I will complete the switch here. And hopefully the radio gets quiet. Everybody ready? Well, it certainly got quiet. I don't want to get that quiet. Let me turn it up now.
We need to look for an alternate right now.
That's the problem.
Still closed off by OPP. They're helping clean up
effective switch
along Davis Drive, right by the 404, where York police are. Now, westbound 401 express direct to transfer by way.
Okay. What is singing in here? Something is just singing. What's that funny sound? I'm sure you can hear that. Usually tube elements vibrating or something, but I don't know what it is. We won't worry about it now. I got enough stuff. Don't look for something else to worry about. So the great thing is, I found out that the reason this thing is blasting out through the amplifier is because this switch is failing to close on the expander. The obvious solution is to put in a new switch. What's not so obvious is where do you get a switch like this? So I have to think about this a little bit now. You know, we could always disable the expander function. You can take that approach, but I'm pretty sure the owner's interest here is to get this radio as reasonably close to its natural or original condition, and that any changes that have occurred in it are just more of its history and less of someone like me chopping everything out of it, sticking all kinds of new stuff back in there. So you got to think about how to handle this. But that's the story anyway. That ends the story on the blasting volume. And I'll bet you that knocks out the hum, or reduces it to the point where it's not important. That's really probably the better way to put it. Okay, well, great. I got somewhere. Well, thanks a lot for watching this video, and we'll think about what to do next with this guy. There's still lots more to do. I think I chopped out the part of the video where I hold up a thermal camera and find out that this resistor is still running very hot at 70, 75 degrees C, and this one over here is not so cool either at 60. So there's still those problems in there. Okay, that's enough. That's enough for today. Thanks a lot for watching, and see you on the next video.